Welcome everybody to this first video tutorial and hopefully a series of many from the Digital Design Resources Library. My name's Dan, and today we're going to be going over a tutorial on how to create this geometry using Rhino and Grasshopper. But what the tutorial will also be is an intro into how Grasshopper uses data and lists and how you can manipulate those lists to affect geometry to get it to do things we want, like this. So you can see this porous surface is created by these individual strips that are kind of twisted along as they're going from one edge to the other, all the way along the surface like that. This would be something obviously very difficult to model in Rhino quickly, but hopefully you'll see how easy this can be to do in Grasshopper, and it should open up all the potential that Grasshopper has and how you use lists and data to create geometry. Alright, so let's get started. What we'll need first is a surface that we'll make in Rhino and then take that over to Grasshopper. So to do that, we're going to start right here with a control point curve, and then just go ahead and make 3 points to make a curve there pretty arbitrarily. Then hit enter. Hit enter again to draw your second curve. I'm going to draw this curve kind of up and over like that. Okay. Select that second curve, type M, enter to move it, V, enter to move it vertically, and then move it vertically about to there, and then select both of them, type loft, and there we have it. That is our surface that we will be using to create our geometry in Grasshopper. So the next thing to do is to open Grasshopper by going into the command line and typing Grasshopper. And here you go, you have your Grasshopper window. It's good to be able to look at your Rhino window and your Grasshopper window simultaneously, so hopefully you have two monitors. It's much easier to do, but it's important to be able to see what you make and how that affects what you do in Grasshopper here. So, how do we get this surface into here? Double click on your canvas and type surface, and then you'll get this surface component to come up. You can also find it under your parameters menu, geometry, surface, right there, either way. So to bring this Rhino surface into Grasshopper, we need to set it to this component, and right now, since it's orange, that means that there is no geometry that it's referencing. So right click on the component, go down to set one surface, and then it'll jump into Rhino, and then select that surface, and there we go. The next thing to do is to highlight all of your geometry in Rhino, and then type hide, because what we have in Grasshopper is what we need to see now. And so when the geometry is rendered red like this, that means it is referenced in Grasshopper, but you can see that it's not, you can't select it in Rhino. It's just a representation of what you have going on in your definition. So the first thing we need to do to this surface is explode it. And to explode, the component is called brep components, but if you just type explode, you'll see that right there. And brep is just basically any sort of geometry you create in Grasshopper that can be exploded using this component. So drag your surface right there, and then you see that what the explode gives us are the faces, edges, and the vertices of the brep. Now, as you remember, what we need are the edges, because those strips that were kind of cut along the surface were then twisted, and so that's going from edge to edge, and so we need to pull out these edges. So how do we do that? First, let's pull up a panel. So double click on your canvas, type panel, and you see this yellow thing come up, and what that is just a way to view any data that's coming out of your components. So if we went ahead and type and plug the surface into here, you see you have what's called a list, what the how the data is represented, and then it says reference surface because we have a surface reference there. There we go. Faces, untrimmed surface because there's just one face of the surface. But let's pull in our edges here. What we need, we see that there are 4 different edges to the surface, numbered 0, 1, 2, 3, because in programming language everything starts with 0, so keep that in mind too. But that makes a lot of sense, right? You have 4 edges to your 4 edges of your surface. Okay, so we need this top and bottom edge, so let's go over how we're going to extract that. So if you bring up a list item by typing item into the command line in Grasshopper, selecting list item, and then drag your edges there into that list. And so what that's doing is taking this list, and then what we need to do is select one of these, and so that's what the item does. So put that edges into your list, and then we need to select one of these one of these indices in the list that are the items that we need. So you can see here that it's numbered 0 through 3, and so what I'm going to do is bring up a slider. And a number slider is just selects a number that you can plug into any sort of input that takes a number. So double click where it says slider, and then we're going to change it to integers, and we're going to go from 0 to 3 because that's the numbers we need to select in that list. So double click on the max there, set it to 3, and you saw I changed from real numbers to integers because we don't need any decimal places. Okay, so now plug that into your indices, but then I would unpreview the surface and the explode, and then you can see how as you pull the slider from 0 to 3, it selects one of the edges at a time. So these items are a really useful tool because you can really just extract any one piece of data from all of this stream that's coming in. So like I was saying, we need that top edge and the bottom edge of the curve. So I'm going to start here with the bottom edge, and then copy that slider and the item. And then right now we have 2 items that are kind of on top of each other since these are both set to 1. But if you set this, right there we go, to 3, which is the top edge there, then we have the 2 items we need. Okay, so kind of remembering back to how that final geometry was made, it was these strips that, again, twisted. And so to get these edges that we need to sort of loft each of those surfaces individually, what we're going to need to do is offset this line so that we can draw a surface perpendicular to where these surfaces are going to be on this curve. So in Grasshopper there is an offset component. Double click and type offset. You can see the offset curve there. And so since we have this item that's only this one curve, we can plug that into the curved offset. And then by default, you'll see here that we have a distance that's set to 1, a plane that's set to the world XY, and then a corner type. So we don't need to worry about either of these because it's already offsetting in the direction that we need, and then we're not changing any of the corners. So what we do want to manipulate here is this distance. So if you remember these sliders that we can use that can change, any input that takes a number, we're going to pull another one of those in. But this time let's go and set that max to 10, and then we're just going to leave that as a real number so we have a little more room to move. So now you can see, plug that in there and drag that, and that'll offset that, the distance that corresponds to the number on your slider. Okay, the next thing we're going to do is get points on all of these curves so that we can draw line segments this way and then this way along these curves that each of those can then individually be lofted to make that twisty surface again. And so to get points on a curve, the component is called divide curve. And so if you double click and type divide, you'll see divide curve is that first one there. And so we're going to need points on all 3 of these curves. So copy that, paste it 3 times there, and then we're going to pull in the offset as this first one. You can see it's divided into points. Pull that bottom curve in, and there we go, and then the top curve. Okay, and so right now you can see it divided it into even segments all the way along each of the curves, and then this end here is the number of segments, and then by default that is set to 10. And so this is something too that we're going to want to have, we want to be able to manipulate while we build this definition, and then also to test variations in the geometry in the end. And so you can actually just, yeah, we're going to pull up another slider here. But a lot like for these ones, the number of points is only going to be an integer. So when I set this slider, set that to integers, and then we're going to make, let's go to 50. Give me a really dense there and see how it does. So plug that same one into the number for each one of the division curves, because we always want the points on these curves, these curves to have even number of points, so that all of the surfaces align with each other. So we can go all the way up to 50 points, and then when you are at 0, obviously there's not too many points there. Okay, so the next thing we need to do is change these lines into segments that can each individually be lofted down to their corresponding segments going perpendicular. So what we're going to do is use a line, and what we need is this line here, because it's like it says in the description, it creates a line between 2 points. So we're going to take these points from here to here, and then what we should get are lines that go across that curve, like that. Okay, and then we need lines going this way across this curve. So what we have are this set of points, but how do we go from this point to this point if they're all in this one component here? What we're going to do is use a component that's called shift, and we'll show you what that does here by bringing it up. Type shift and select that shift list, and then take this panel that we used back over here and copy and paste that. But now plug in your divide and see what's coming through there, and what it is the series of points that are making up this line. They're all in coordinates. But if we take this divide and then we shift it, it says the shift offset, and then by default that's set to 1, and then which is what we need, because as you can see here, when we pull another panel into the shift, it took that first value and made it, you know, what this second one is. So it shifted all those up. So now we have a set of points that are going from, you know, starting at this point to this point to this point to this point to this point, and then when we shift it, then we have a series of points that are going from starting at the second point going over. So now we can draw a line between each one of these segments. So copy and paste your line here, and then into A and B we're going to plug in this to that. There we go. Okay, and so now those lines are going all the way across those segments, and then we can go ahead and loft all of those down. So there is a loft component in Grasshopper to loft two surfaces together, so we're going to go ahead and pull that line into the curve for the loft, section curves, and then hold shift to pull multiple into a component, and then drag that second line there, and then do that. And whoa, what's going on? Right, that's not the geometry that we want. So there's a few things that we need to change in our definition in order to make this logic that we've set up work. The first thing we need to do is realize that when these surfaces are drawn, each of these curves have a direction. And why that's important is because in order for us to be able to loft this surface down to this surface, we need to make sure that this surface is the first surface, just like this one is the first surface, or you know, they're all in line, instead of this one having to go all the way over here and this one having to go all the way over there. Like you kind of see that last loft went across this way because this segment was in the same, was the first one in order there, and it kind of went down and across. So we know that when we draw the surface, we can assume that whichever direction this is going, this goes from this edge up and then back the opposite direction. And so what we're going to do is we're going to take the line, this bottom line here. I'm going to go ahead and unpreview this so this will be easier to see. So we're going to take this top line, and then we're going to use flip, and this is one is flip curve. So we're taking the curve and then essentially flipping its direction. It's not really like mirroring, it's just going to flip the curve. See, the geometry didn't change at all just because that direction is going. So now these two curves are parallel to each other, and so all the data going across them are going in the same direction, which is important for us to get what we want. Okay, and so instead of dividing this curve that was going the wrong direction, we're going to pull that into divide and it'll replace that. And then you can see how the points changed as it changed directions. Basically just reverse the whole list. Okay, so then let's try this again. We'll go ahead and loft these together and see if that fixed it. Oh, nope, not really. Still not doing what we wanted to do. So what is possibly going wrong here? Well, it just seems like it's taking these line to line and not really going in the order that we wanted, since they're all set up in the same kind of list. The data is coming in for each of these control points and each of these lines kind of in the same sort of way, but they're not lofting together in order. And so one way we could do that and make sure they loft together in order is to see first here what's coming out of this list of lines. These 17 lines with these 17 lines, we could go ahead and pull each one of those items out individually and then loft those. Well, that's a lot of very tedious work, and what Grasshopper has the ability to do, that's one of its most powerful tools, is create data trees. And there's a whole new set of tutorials that you can look up that talk about what a data tree does, but in short, what it's going to do for us is allow us to take each one of these 17 items of lines and line them up with the 17 items here, because they're going to be structured in the same way and not sort of going down one list and then down another list, so jump back and forth between them. So what we need to pull up is the graph component, and what graph does is takes any list of data and converts it into a data tree. So we're going to pull the line here in a graph, and now let's again pull another panel up and take a look at what that did to our data. Go ahead and delete this. Like I said, so this was what we had originally. Okay, so we're at we have these 17 lines as they came in originally, but then we grafted it, and then you can see as this comes up into a dotted line, maybe dash line, excuse me, that means that it's going into a tree, and then you see how it's organized now. And where how this line was organized with just kind of this one bar and then this whole list, you can see here that this is each in its own sort of list, and what that means is that it's in a data tree. Trees can be very confusing, but they are extremely helpful in this case. As you can see, once we graph both of these lines to get data that's also organized in the same exact way, we then loft these surfaces together, and voila, you have the geometry we were wanting to do in the first place. Okay, and so the other thing that we can do now is that we set up these parameters to make variations in our final geometry here, so we can test the density and scroll this up and down, and as it creates more points along that divide curve, since everything is arranged in this linear fashion, then it changes everything, and we can test how dense it is and also how far this offset goes. So there you have it. You can go ahead and bake this and make some sweet rendering. Ooh.